Here you could see the graph of an ellipse and its equation written in standard form. Notice as I move these points around here, the equation changes. Here we can see the anatomy of the ellipse, the graph of the ellipse, and its equation themselves. The parameters there are color-coded, as you can see right there. Here, an ellipse has a major axis. In this case, it's going horizontal, and it has a smaller minor axis right there. Here, the major axis is 10, and the minor axis is 4. But we can now make the minor axis 6 and 8, 10, 12, and when the minor axis is now the major axis, as you can see right there. So when the major axis is vertical, right, notice that the bigger denominator is under the y squared term, right? And when the major axis is horizontal, then the bigger denominator is under the x squared, as you can see right there. And of course, just like any function, I know this is not a function, but with any graph, we can move the graph left and right. Right, subtracting an input or adding an input moves it right and left, and adding and subtracting from an output moves it up and down, as you can see right here. So you can still see the same structural changes apply here as in the graph of other functions, right? But let me ask you this. What would happen if the major axis and the minor axis of this ellipse became equal, right? There we go. What if we made the minor axis 5? Ooh, what kind of conic section do we have here? Yeah, that's a circle. So a circle is a special case of an ellipse where the major and minor axes are equal, as you can see right here. So if you go to that tiny URL, you'll see it, and you can play with it, explore it, and have fun.